Now in this video I'm going to show you how we derive this formula simply, right? But first of all, we're going to try and look at let's say you have 5, right? Let's say you have 5 plus 7 plus 9 and then plus 11, right? Let's say you want to add these terms. How many are they? They are 4, right? 1, 2, 3, 4. So this is the sum of 4 terms. Okay, so how about we call this our equation 1? Now these numbers, if I were to start right with 11, then go to 9, 7 and 5, it will still be the same thing because we are adding. So if I reverse the equation 1, right, I will have 11 plus 9 plus 7 plus 5. It is still giving me the same answer because it's addition. So I can then call this equation 2. Now if I were to add equation 1 plus equation 2, what would I get? S4 plus S4 is 2S4, and then 5 plus this is 16, 7 plus that is 16, 9 plus that is 16, 11 plus that is 16. Wow, I got 16, 16, 16, the same answer. How many 16s do I get? Like how many 16ths sorry for that, do I get? Or how many of these numbers do I get? Well, the terms were 1, 2, 3, 4. The terms were 4. The terms were 4. So I got 4 times 16, right? I got 4 times 16, and then with it, because the terms are 4 that I'm dealing with, then now I'm going to divide by 2 both sides, divide by 2. Therefore the sum of 4 terms would be 32. I found the addition of 1, 2, 3, 4 using this method, and you can confirm 5 plus 7 is 12, 12 plus 9 is 21, and then 21 plus 11 is 32. You see, so using the same approach, that's how we're going to derive an arithmetic formula. Now an arithmetic formula is a plus d and stuff. Why? Because check, let's say this is my arithmetic formula here, right? This first term is a, right? A stands for the first term, then d is the difference. So to get this term, I say a plus d, which is a plus d, right? And then remember, it is a constant difference. To get this term, I'll say a plus d, it will be a plus 2d. You see, then that's why we got this as our first term, second term, third term, and then the last term. Okay, that's our last term there. Now the last term is actually this thing, it's actually tn. Okay, it's actually tn. Now we can call this our equation. This is the sum of n terms. We can call this equation 1. It's the sum of n terms. Okay, because there are n terms in this. Now we're going to do like what we do in the previous one. We're going to reverse this, and when you reverse it, we'll have Sn is equal to, now we start with the last term. We're going to have a plus n minus 1 d. This is the last term. But now when I go to the second last term, it's going to be a plus n minus 2d. Just remember that. The third last term would be a plus n minus 3d. And then the first term would be a. I start with the last until the first. Then I call this equation 2. Then after that, I'm going to add now. Equation 1 plus equation 2. Sn plus Sn is 2Sn. Now a plus a is 2a, and then plus this n minus 1d. Now, good people, you just have to get this one. Then you say you're gonna get the very same thing here. A plus A is gonna be 2A, right? It's gonna be 2A plus n minus 1d. Okay, so that's what we're going to continue getting. How many of these are you gonna get? You're gonna get n of those. The same way here we got 4/16. Even here we're gonna get n of these. So you're gonna have 2Sn is equals to n into 2A plus n minus 1d. Then you divide by 2 both sides. Sn would be n over 2A plus n minus 1d. Then you have proved it.